Hello everyone, welcome to another video. I did work with IFC files lately. You have some two paths that you will need to follow, and I also want to tell you my opinion about that. If you need to do anything with IFC files, maybe this video will help you. Over here, I'm in the MEP model. I'm using as a Revit link one file, which is a Revit file. It is the same file. Basically, I have just two walls, and the other file is IFC file. And I want to show you what is the difference. And yes, we can maybe insert both of them, and then we will just, yeah, that's a good idea. Cool. So now Revit walls are green and IFC walls are gray. And now I want to show you essentially where we have differences when we are talk about work with Revit links and IFC links. So over here I have a couple of nodes which allow me to select some element and some link. Over here I did select those couple of ducts, and now for example we need to find what is the let's say thickness of the wall. So when you have IFC file and you want to find thickness of the wall, either you will read some parameter, and if you can expect that I don't know, next time when you receive IFC files that you will have the same parameters, and then for some parameter you will find some value and you can rely on that value, then that is a good thing. So if you do not receive IFC file from multiple sources, from some big number of people which will map elements differently, then that is a good way. So you can then read the parameter, and you will read that we have over here thickness of 200 millimeters, and that's it. From another perspective, if you want to find the thickness or width of the wall, then you can just, if that file and the element is belonging to the Revit element, then you can read the width of the wall. And you don't have that in the IFC. So if we select that element over here and we go edit type, we don't have that width parameter. Okay, and I want to show you how you can basically recognize what is the width of any wall from IFC. So I will hide this Revit file over here. And let's say that we need to find what is the width of any wall. So I'm using this method when I need to find basically clashes with the walls, and when we need to create automatically openings for the wall. So in order to place my family and to have proper thickness or depth of that family, I need to know what is the thickness of the wall. Okay, so we have our wall. We did select that by using this. This is a GeniusLoci node. So it's a GeniusLoci node. This is Revit 2023 with Dynamo. Which version? It's over here now. 2.13. Okay. And now I will do some trick. So I want to pick any of those MEP elements. So it doesn't matter if you have over here cable tray or pipe or duct. If that duct is round or rectangular, it actually doesn't matter. So from the list of 3 elements, I want to pick any of those elements. I want to have get location for those elements. And what is really good that you know when you want to work with linked elements and you have IFC as a link. When you have IFC wall, and I mean Revit will show you that this element over here belongs to the category of the wall. But nevertheless, even if Revit know that is a wall and Dynamo know that is a wall, you will not have over here output if you want to get to know the location of the wall. If that is a Revit element and you want to get to know location of the Revit wall element through the link, you will receive information regarding the location of the wall, and you will have line, and you can then take that line and use it to find direction of the wall in order to find the rotation angle of your elements. So if we run the script and if we turn on Revit link over here and we say run, we want to use this element, finish, and over here when we take a look, so if we are using Revit link and we want to grab that wall and we want to get to know that location, basically Dynamo will show us. If we are using IFC, we will not have location over here, but what is very good is this node over here. So if we want to convert our element to geometry, because it is a wall, from the Revit link we will have the solid. But if you are asking Dynamo to convert element to geometry for the element that belongs to the IFC element, then you will actually have solid element, and now you will have that line which represent the location of the wall, which is very good. So again, that is some trick that you can use to use that line in order to find the angle of that wall and to place some families on that wall. Okay, that is okay, but we want to find the thickness, and we don't want to use any of those parameters because let's say that we cannot rely on them. Maybe someone will change parameter's name or something, so our script would not be the same in that case. So now we did took one of our elements which is going through the wall, and we have the line, and now we will intercept what we will intercept. From one side we will took our line, from the other side we will took solid. So in this case our solid is at index 0. Run. And what we will have as a output as a result of this node over here. I will try to draw, and I will draw some large thickness, something like that, for example. So, and we want to know that thickness, and we have some MEP element going through the wall. It doesn't matter if it's a pipe, cable tray, conduit, or duct, and which version of duct, any version of duct will work. And when we call that geometry intercept, what the Dynamo will do, Dynamo will look the geometry number 1 and geometry number 2, and it will only remain after that node just those pieces of the element which does intercept. So from our line, this will fall off, and also this. So the only piece of the line that will remain is the line going through the wall, and that is very good for us. You can do previous to this check, some check if you want to see if the line is going to the straight direction through the wall, because if you have some line going in this direction and you want to find the length of that piece over here, then you will not have correct answer because your line is going by some angle through the wall. But over here we did so visually that our elements are going in the straight to the wall, and usually MP elements going in the straight direction. So now the only thing which we need to do is, because the intersection between the solid and the line is just this portion of the line, now the only thing which we need to do is to ask Dynamo to tell us what is the length of this line. You have a lot of different lengths. We need to this one. Run. And you will have some decimal places. You can round. We can round this. And now we will have our thickness. So you could rely on something, but you can also use a little bit of math and a little bit of geometrical nodes to find what is the thickness of the wall. The same is with the floor, and the same or similar is when you want to know what is the width and height of your element. So you can either create like bounding box or any other element, and then you will just need to read what dimensions you have for that bounding box for the height and the width. You can also try to find the thickness of the wall if you want to know the length of that bounding box, but sometimes you will have incorrect results. I would say in the most cases you will have incorrect results, but you can try and you can compare it to this case over here. And that is it for this video. If you have any question regarding the work with IFC, you can leave a comment and I will try to answer. Bye.